Same FRQ again, new question. Find f of -3 and f of 4. Again, don't do two things at once. So we're going to focus on finding f of -3 first. Box on the front of the golden notes is key. It's on the right-hand side about halfway down. When you are giving a rate, when you are given a rate, we're given f prime. That's the rate at which f changes. They gave us that rate as a graph, and they're asking us to find an amount. Because Danica's chart tells us that the amount here, that's f, they're giving us the rate f prime. So when I'm given a rate and I'm supposed to find an amount, I use the fundamental theorem. Unless our formula for rate includes an output variable, then we have to use the Sassy method. But with a graph of f prime, we can go ahead and use the fundamental theorem. So here's the fundamental theorem. It associates the integral of f prime with the change in f. So I take this equation and I write it out. So I'm going to have the integral, let's change color here, from, let's see, here's the key. I know the value of f at x equals 0. So I'm going to start here at x equals 0. I'm going to integrate to -3. Except that I don't really like going backwards. 0 to -3 would be integrating backwards. I prefer not, so let's write it the other way. So I'll have the integral from -3 to 0 of f prime according to the fundamental theorem. Always top, subtract bottom. This is f prime, this must be f. Rearranging to solve for this means I'm going to add this to both sides. So that will give me, so we're kind of running out of space here. Let's make a copy of the, well, I think we can fit it in. So we're going to add this to this side. That means we're going to subtract the integral to that side. So we're going to get the equation that's right here. F of 3, -3, because this was negative, we added it over, it became positive. That will equal this got subtracted to the other side, so we get this equation. This is my equation for finding f of -3. I already know f of 0 is 3, because they told me I need to find the value of this integral. One way to find the value of an integral is by calculating the appropriate area. I'm going to go from x equal -3 to x equals 0. Okay, along here we're integrating f prime. Along here the values of f prime are all positive. Therefore, as this area is integrated, this area will be counted positively because these values of f prime are positive. This area is 1 by 1. 1 times 1 is 1. Half of that is a half. So that area is a half, and in terms of finding the value of the integral, that gets counted as a positive value. Here's the minus, here's the minus. F of 0 is 3, here's f of 0. So 3 minus, I need a parenthesis because I've got two terms here. The 1/2 is positive because this area was positive. Then over here, now all of these y-coordinates of f prime are negative. Hence, the integral counts all of this value as negative. The area would be 2 multiplied by 2, which is 4, divided by 2 is an area of 2. But the integral counts that value as a negative because of the fact that all of these f prime values, we're integrating f prime, all of those f prime values are negative. I do not need to do the arithmetic. It's safest to just stop. Here's f of 0. This thing in the parentheses is the value of the integral. You get 1 point if you did that part of the problem correct, the integral. 2 points if you have f of negative 3 equals 3 minus this. This is a bit of a mistake. We should fix this real quick. This box here should really only show that much. You won't get the point for showing this. You had to get to here to get the full 2 points. So 2 points total for part 4. Well, back up a minute. That's for finding f of 3, f of negative 3. So that's 2 points right there that we have earned. Now we're going to move on and find f of 4. And I believe that's also going to be worth 2 points. So moving ahead here on the board, now we're going to find f of 4. We once again use the fundamental theorem because we have a graph of f prime, but we're trying to find a value of f. So we write down the integral. This time we can go from x equals 0 to x equal 4. We integrate f prime. That must equal how much has f changed between x equal 4 and x equal 0. Rearranging for f of 4, we simply add the f of 0 to this side. We get this equation. So once again, this green box is highlighting a bit too much. So we'll fix the wrong one. Fix the green box. So we have to figure out this, which means we need this integral. Because we know f of 0 is 3, so here's 3 plus, now we're going to integrate from 0 to 4. So we start at 0, go all the way to 4. We are integrating f prime. So we're finding values of f prime. The values of f prime are all along here. They're all negative. So when integrating f prime, all of these f prime values are negative, hence this area will get counted as a negative. If we keep going, these values of f prime are still negative. So all of this area gets counted as a negative as well, all of this area in here. So the area we are focused on, turn on our highlighter, so we're focused on the area here. As well as the area here. Both of those areas are completely below the x-axis. They're where f prime has negative y-coordinates. Here's f prime being negative. So both of these areas will count as a negative. That's why you see here f of 4 equals f of 0 plus the integral. F of 0 is 3. There's the plus. But I put a negative here because all of this integral is going to be some negative value. I'm going to find the purple area, and I must declare that area to be counted as a negative in terms of calculating this integral. So to find the purple area, I first am going to find, choose green, the area of this rectangle. When they ask you to compute an integral, by finding areas geometrically, they will give you shapes that are either rectangles, triangles, or semicircles or circles. I've never seen them give you anything else. So the area of the green is 2 by 4, that's 8. So the area of the green rectangle is 8. I don't want the area of the green rectangle, I want the area of the green subtract the area of this orange circle, semicircle, I'm going to calculate the area of the green rectangle, which was 8, and then I calculate the area of this orange semicircle. I remember that the area of a semicircle is pi over 8 diameter squared. So that's what I've written down here. For some reason I feel compelled to fill in the shape. So the area of this semicircle is, the diameter of the semicircle is 4. Pi over 8, diameter squared. Be very careful with your parentheses. These two parentheses are necessary to indicate that this is the value of the integral. Only the 4 is being squared. You don't have to work anything out. This entire integral's value will be considered to be negative because this purple area is definitely below the x-axis. So this would give you 2 more points if you have all of this right here. If you somehow found this area correctly but didn't include the 3, they would give you 1 of the 2 points.